Okay, I'm going to go through a little demonstration of the type of how to fill out your data table. So let me share uh, the the screen. Let's see. This is it. This is I'm using physics.bu.edu, the tilde Duffy HTML5 speed of sound.html. Yeah, I don't know uh, this person, but it's a nice demonstration, and so we're gonna use it. You can select three different tuning forks: 440, 512. I'm going to choose 660 hertz, 660 hertz, and I'll show you um, how we fill it out. So I'm going to be switching back and forth um, between the iPad and the uh, demonstration, just so you can see exactly how we're going to fill this out. So here's your data table. I already have the 25 degrees C, and I have the 0.0217 meters inside diameter. So we're going to choose 660 hertz, and that's our frequency. And the position of the resonance is going to be in meters, and the delta L is going to be in meters. And the first, we'll go back to um, the simulation, and right here. Okay, so our key here is to look for the first the first resonance, and what we want to do is we want to maximize the the um, uh, the waveform. In other words, if I move down a little bit, you can see how it decreases. If I move it up a little bit, you can see it decreases. So we want to get it right where it's at the max, and it looks like it's at 13 centimeters. I'm reading it right here, 13 centimeters. So that's our L1. That's the first quarter wave resonance. So let's write that in, 13 centimeters. As soon as I know you can see it, I'm going to write down um, 13 centimeters is 0.13 meters. Okay, so that's the first, that's L1. No data is associated with it. You can see that how it's X'd out there. So we have the 0.13. Let's go back to the um, simulation, and there it is. And so now we're going to look for the next resonance. Okay, and let's see if we can maximize this. And that's about max. I'm going to say 39 centimeters, 0.39 meters. So let's fill that in. Zero 0.39. Now, the delta L, we can at this point see if we just take 39, subtract 13, we'll get 26. We'll get 26 centimeters, 0.26 meters. That is a half lambda. This first one here, that's a quarter lambda. Between here and here, that's an increase of half a lambda. So that's the difference there. Okay, let's go back and let's find the next resonance. Okay, let's lower the water level. Oops. Oh, yeah. And let's try to maximize it. There I get 65. Oops, that was chose the wrong one. 0.65. And if we subtract 0.39 from 0.65, well, again, we're going to get 0.26. And I don't know if we can get a third. Let's try it. I don't recall if it doesn't look like it's going to get much further, and we can't. So those are the only two that we get. Those are the only two that we get. So let's show you how to fill out the rest of it. Now, this isn't, you're not going to be using 660. This is just for demonstration purposes. So the average is 0.26. And so that's half lambda. So if you double that, you're going to get the average lambda, the average length. So that's 0.52. 0.52 0.52 is the wavelength of the wave that we're looking at. So if you let's see, we have I always remember distance equals rate times time. That's the one I learned in grade school. So the distance is your lambda. The rate is your the velocity of sound in air, and t is the time, which is the period. Well, 1 over f is equal to t, so we divided by the frequency. So we want to solve for the velocity. The velocity is equal to lambda lambda times frequency. So we've got 0.52 meters times 660 cycles per second. We can even call this meters per cycle, because that's a wavelength. Lambda is a wavelength, so it's 0.52 meters per cycle, 660 cycles per second. The cycles are going to cancel out, and we're going to get meters per second. So let's do 0.52 meters, and then 660. I get 343. 343.2 meters per second. Now, you're going to get more like 345 for, this was just a simulation. There was no air temperature. At least I don't recall them setting in that air temperature. But this is how you would go about measuring the velocity of sound in air. So you're going to do it. You're going to do it for one. Well, I've done it. I've done it. But you're going to record the data, watching the video that I posted. You're going to do that and watch the video, take the data, and you'll go through these same calculations. Okay, and that's the end of the demo. I think this will help you fill out the data table without much trouble.